What if I told you that the moment your finger made contact with a black hole, you'd experience something so bizarre that it defies everything you think you know about reality? Today, we're diving deep into one of the most mind-bending scenarios in astrophysics, and trust me, the truth is far stranger than any science fiction movie has ever portrayed. Before we get into the absolutely terrifying details of what touching a black hole would do to you, let me paint you a picture of what we're actually dealing with here. A black hole isn't just some cosmic vacuum cleaner floating around in space. It's a region where gravity has become so incredibly intense that it literally warps the fabric of space and time itself. Imagine taking a bowling ball and placing it on a stretched rubber sheet. The ball creates a depression, right? Now imagine that depression becoming so deep that anything rolling nearby gets trapped forever. That's essentially what a black hole does to space itself. But here's where things get really interesting. Black holes come in different sizes, and the size actually determines how your touching experience would unfold. We've got stellar mass black holes, which form when massive stars collapse, and then we've got the absolute monsters called supermassive black holes that lurk at the centers of galaxies. The one at the center of our own Milky Way, called Sagittarius A star, has a mass equivalent to about 4 million of our suns. Just try to wrap your head around that number for a second. Now let's talk about what happens when you get close to one of these cosmic beasts. As you approach a black hole, you'd first encounter something called the photon sphere. This is a region where light itself can orbit the black hole. Imagine photons, which normally travel in straight lines, being forced to curve around in circles. If you had a mirror at this distance, you could theoretically see the back of your own head. The light from behind you would curve all the way around the black hole and come back to your eyes. It's like the ultimate cosmic selfie, except you're probably not going to live long enough to appreciate it. But we're not stopping at the photon sphere. You want to touch this thing, so let's keep going inward. The next major milestone is the event horizon, and this is where things get absolutely wild. The event horizon isn't a physical surface you can actually touch. It's more like an invisible boundary, a point of no return. Once you cross this line, not even light can escape, which means you're definitely not making it back home for dinner. Here's where the science gets truly mind-boggling. According to Einstein's theory of relativity, time itself behaves differently near black holes. As you approach the event horizon, time dilation kicks in big time. From your perspective, everything seems normal. You're just floating through space, maybe wondering why you made such a questionable life choice. But to someone watching you from a safe distance, something incredible happens. They would see you slowing down dramatically as you approach the event horizon. Your movements would become sluggish. Your watch would tick slower and slower, until eventually you'd appear to freeze completely at the edge. But wait, it gets even weirder. Due to the intense gravitational field, light coming from you would become redshifted. This means you'd appear to change color, shifting toward the red end of the spectrum, and eventually fading from view entirely. To the outside observer, you'd effectively disappear, frozen in time at the boundary of the black hole. Meanwhile, from your perspective, you'd continue falling inward, completely unaware that the outside universe thinks you've stopped. Now let's talk about the really uncomfortable part. As you fall toward the center of the black hole, you'd experience something that physicists have given the rather ominous name of spaghettification. This isn't as delicious as it sounds. The gravitational force at your feet would be significantly stronger than the force at your head because your feet are closer to the center of the black hole. This difference in gravitational pull is called a tidal force, and it would literally stretch you out like a piece of spaghetti. For smaller black holes, this stretching would happen relatively far from the center, tearing you apart long before you could touch anything resembling a surface. But here's a fascinating twist. If you were falling into a supermassive black hole, the spaghettification would happen much closer to the center. You might actually cross the event horizon while still in one piece, continuing your journey inward for quite some time before the tidal forces became unbearable. So what exactly would you be trying to touch down there? This is where our understanding of physics starts to break down completely. At the very center of a black hole lies something called a singularity. This is a point where our current theories predict that density becomes infinite and space-time curvature becomes infinite. It's a place where the normal rules of physics simply don't apply anymore. Some physicists think the singularity might not actually exist as we imagine it, and that quantum effects might prevent such an extreme situation from occurring. But let's assume you somehow managed to reach this mysterious center. What would you find? The honest answer is that nobody knows for sure. You might encounter some form of exotic matter, or perhaps the very structure of reality itself breaks down at this point. Some theories suggest that space and time might become so warped that the concepts of touching or physical contact lose all meaning. There's another absolutely mind-bending aspect to consider. Some physicists have proposed that black holes might be connected to other regions of space-time through structures called wormholes. If this were true, touching the center of a black hole might not destroy you, but instead transport you to some other location in the universe, or even to a different universe entirely. Of course, this is highly speculative, and the journey would likely be so violent that survival would be impossible anyway. Here's something that might surprise you. Black holes aren't actually black in the traditional sense. They emit something called Hawking radiation, named after the brilliant physicist Stephen Hawking. This radiation is caused by quantum effects near the event horizon, and it means that black holes actually evaporate over time. For stellar mass black holes, this process takes an incredibly long time, much longer than the current age of the universe. But smaller black holes would evaporate faster, and hypothetical microscopic black holes would disappear almost instantly in a burst of energy. The temperature of this Hawking radiation is inversely related to the mass of the black hole. Counterintuitively, this means that smaller black holes are actually hotter than larger ones. A black hole with the mass of our Sun would have a temperature of only about 60 billionths of a degree above absolute zero. But a black hole the size of a mountain would be incredibly hot, hotter than the core of the Sun. If you're finding this journey into the bizarre world of black holes as mind-bending as I am, consider hitting that subscribe button to join our cosmic explorations. Now let's address the elephant in the room. Could you actually survive touching a black hole? The short answer is absolutely not, at least not in any conventional sense. Long before you could make physical contact with anything, the extreme gravitational forces would tear apart every atom in your body. The intense radiation environment near the black hole would cook you with high-energy particles and electromagnetic radiation. Even if you somehow had a magical spaceship that could protect you from all these effects, the fundamental nature of space and time near a black hole would make the concept of touching something increasingly meaningless. But here's what's truly fascinating about all this. The study of black holes has revolutionized our understanding of physics in ways that extend far beyond these cosmic monsters themselves. The information paradox, which asks what happens to information that falls into a black hole, has led to groundbreaking insights about the nature of reality itself. Some physicists now believe that the surface area of a black hole's event horizon is directly related to the amount of information it contains, suggesting that our three-dimensional reality might actually be encoded on a two-dimensional surface. Recent developments in black hole research have been absolutely incredible. We've now actually photographed the event horizon of a supermassive black hole using a network of radio telescopes called the Event Horizon Telescope. We've detected gravitational waves from black hole mergers using facilities like LIGO. These discoveries are giving us unprecedented insights into these mysterious objects and confirming many of Einstein's predictions about gravity and space-time. So while you'll never actually be able to touch a black hole and live to tell about it, the mere thought experiment of trying has pushed the boundaries of human knowledge in extraordinary ways. Black holes continue to be some of the most fascinating and extreme objects in our universe, serving as natural laboratories for testing our most fundamental theories about reality itself. They remind us that the universe is far stranger and more wonderful than our everyday experiences might suggest, and that there are still incredible mysteries out there waiting to be solved. The next time you look up at the night sky, remember that somewhere out there, These cosmic giants are warping space and time in ways that would make your head spin, literally bending the very fabric of reality around them. If you're ready for more cosmic adventures, make sure to subscribe for more incredible science and space content. And don't go anywhere. Another amazing video is waiting for you right here.